do it. So, first of all, how do we know that this has to be a minimum? Good. The A value, not because it's smaller than 1. The A value is positive. Do you guys agree? And if it's positive, that means my graph is going to look like a U or an N? Like a U. So if it looks like a U, is this value a minimum or a maximum? This is the minimum, okay? So it told you it was a minimum to start with, so we didn't actually have to do that, okay? So you should have found the axis of symmetry. What's the formula, Christian? What's the fraction thingy for the axis of symmetry?
It's the AOS is like x equals negative b over 2a.
I'm so glad you have that memorized, okay? So what's my b value here, Caden? Okay, so it's going to be negative 3/4 over 2 times what? 1/4. Very good. What do I do now? What? Okay, what's 1/4 times 2? Very good, 1/2. So this is going to be negative 3/4 divided by 1/2, 1/2. What do I do from there? Andrea?
I set it up without the fraction mark. I put negative 3/4 divided by 1/2.
Excellent. Very good. This is KCF. Keep, change, flip. So negative 3/4 stays the same. What did you change?
I changed the division sign from
3/1. Very good. What did you get here? Excellent. We can reduce that to negative 3/2. How many of us got the axis of symmetry? Hey-yo. Go ahead, Gabe. Okay. So what do I do once I have the axis of symmetry, the AOS? Natalie?
You plug it into the equation.
Excellent. Walk me through it.
So I did 1/4 times negative 3/2 squared plus 3/4 times negative 3/2 plus 1.
And then plus 1?
Yeah.
Okay.
And then after that, I started by doing negative 3/2 squared.
Okay.
Plus negative 3/2 times negative 3/2. And I got 9/4.
Excellent.
And then 1/4 times 9/4 is 9/16.
So this is going to be 9/16. Good.
And then I started doing the next step, which was 3/4 times negative 3/2.
Mm-hmm.
And I got negative 9/8.
Excellent.
And then I added the 1 down, and I know that I had to change the denominator to be 16.
Mm-hmm.
So I multiplied the top and the bottom by 2.
What'd you get?
Negative 18/16.
Good.
And then I added the 1, and it has to be a 16 too. It's 16/16.
Good, because 16/16 is just 1. Love
And
it.
then I added the first 2, and I got negative 9/16. And then plus 16/16. And then I got the answer, which is 7/16.
Very good. 7/16 is the correct. I know some of you just missed it by a negative. Others got very, very close. Some of you got 1/2, which was 8/16. Okay. Make sure, okay, that you understand every single part of this problem. What questions do we have on this one? Everything. The whole thing, McCarvin? So you didn't do well on the homework last night. All right, then let's talk about the homework then. Okay, guys, from here I want you to, okay? Now, we've heard the words or the terms even and odd before, right? What does even normally mean? They're okay, numbers that are evenly divisible by what? 2. What are odd numbers? So they're the numbers, do you agree that they're the numbers between the even ones? So it goes like even number, odd number, odd number, right? So forget everything that you learned about even and odd when you talk about numbers. When we talk about functions, okay, even functions are ones where if you plug in negative x where x is in your function, it will not change the function at all. It will remain the exact same. So plugging in negative x for f of x will result in getting f of x. Again, circle that right there, okay? That is for even functions. Now, in odd functions, okay, when you plug in negative x, you do not get the exact same function. You get the negative version of that function. So the entire function turns negative. In other words, if there were 3 terms in that function, all 3 of them would change signs. If there was 1 term in the function, that 1 term would change signs. But if you plug in negative x for x, it would become negative f of x. Yes?
So if you get a positive answer, it's most likely even?
Well, depends on if you started with a negative, right? So what if you started, Gabe, with like f of x equals negative x, right? That was your original function. And if we plugged in negative x, if we plugged in negative x here, right? Do you agree it would be negative x now? What's the negative x? It would be positive x. So based on your logic, you're saying, oh, that should be even, right? Because it turned into a positive. But how does it relate to your original function? If our original function was negative, didn't we change sign?
Yes.
So this one's actually odd, okay? And we're gonna see more of this, okay? So let's go ahead. I love to explain this as we kind of do our first example. So let's look at letter A. We're gonna do exactly what Gabe just said. We're gonna plug in negative x. So we're gonna say f of negative x equals 2 times negative x. Wherever I see an x, what am I plugging in, guys? No. Wherever I see an x, what have I just plugged in? A negative x. You want to see how that negative x is going to affect your graph. Yeah.
I don't understand why it's negative.
It's just the standard for testing even or odd. Okay? We're going to do this for every single problem. Okay. So we're going to go ahead and say, okay, f of negative x equals, what is 2 times negative x? It's negative 2x. So guys, look at the original and look at where you ended up. Has my function changed sign? Did it change sign by exactly 1 negative? Bingo. So what I'm going to say is f of negative x is the same as negative f of x, which means this function is even or odd? Odd. Look back at the example, okay? If it changes sign, it is considered odd. Did it change sign here? Okay? If it was even, the negative x would not affect your graph at all. You would get the exact same function after you plug in negative x. Yes?
Well, like the f of x equals 2x, will it always be positive x?
Where?
Like in the very first one.
Yep.
It's always gonna be positive.
No. We could have a negative there as well. Okay, so be on the lookout for that. Good question.
So if it changes, it's odd.
Correct. If the sign changes of the function, it is odd. Okay?
And if it doesn't change, it's even.
Correct. Yes?
But like, how would it change? Because doesn't it change either way?
We'll see an example where it doesn't change. Okay? What other questions? These are really good questions. What other questions do we have on example A? Do you want to see one where it's even? Okay. Check out letter B. We're going to plug in what for x? So plug in negative x. You're going to get, make sure you use parentheses, negative x squared minus 2. What happens when you square negative x?
Cancels out.
What cancels out?
Negative.
Very good. Because a negative times a negative is a? So do you guys agree that this is the same as x squared minus 2? Did my function change at all?
No.
So the negative did not affect my function, correct? This is an example of an even function, okay? Because we started with x squared minus 2. When we plugged in negative x, we got x squared minus 2, the exact same function. We're going to write g of negative x was the same as g of x. Therefore, this is even. Talk to me. Yeah,
For your final answer, you just need to put even?
correct. That's all this question was asking. Was it even or was it odd? Yes.
If there's an exponent, will it always be even?
No. Because what if you cube a negative?
No, or if it's squared, it will always be negative.
No. Okay? Karen?
How come when you cube it, it's like it's positive now, but like you don't remove the cube? Why is that?
So cubing it would be different because that would be a negative times a negative times a negative. So only two of the negatives would cancel out. You'd still have a third negative if it was cubed. Remember, this one is squared, Karen. Okay? So when you square something, you multiply it by itself. Two negatives multiplied together do give us a positive.
Yeah, but why is it still cubed? If you multiply it together?
So this isn't a cubed one, right? Why is it still squared? Because it's negative x times negative x, right? Negative x times negative x, right? You agree that these two negatives cancel? So we just have x times x. What's x times x? X to the second power. Okay? So we have negative x squared. When you square it, it just becomes x to the second power. Okay? Mia, did you have a question?
I don't understand how, like, what didn't change?
What do you mean what didn't change? Oh, look. It's the exact same function. Do you see that? Look at the previous example. It started as 2x. What did it become? Negative 2x. Do you see the difference there? The one in the second one, it didn't change the function at all. It stayed the exact same. Okay? All right, let's look at example C. Yes, Matthew.
It says, what if we guess like even or odd?
You gotta show me work, okay? All right. That's a reasonable question though. Okay, letter C. We've got 2x squared plus x minus 2. What am I gonna do? Plug in negative x. So it's gonna be h of negative x equals 2 times negative x squared plus negative x minus 2. Who's like very comfortable with this step? Who's like following me plugging in negative x? Okay, cool. What do I do here now? Salucci? Good, you evaluate the exponent, exactly. What do I get when I evaluate this exponent?
2 times positive x would be 2x. And then you get plus the negative x.
Don't forget the squared. Then you do get negative x and then minus 2. And we don't actually technically need these parentheses, right? So, now look back, guys. You're thinking it's odd because what changed? The x term, right? But I want you guys to really look at this. Odd functions say that this would have to be, the entire function would need to change sign, correct? So this would need to be negative 2x squared minus x plus 2, right? I said if it had 3 terms, all of them would need to change sign, correct? Does this match this or this? So guess what it is?
Neither.
It's neither. Okay? So it is possible for a function to be neither even nor odd. Okay? What do you mean we did all the work for
I actually
nothing?
did everything like this.
They solved the whole thing.
Caitlin.
Where did they
Yup.
x to the second?
So the negative 2x to the second minus x plus 2, that came from, I'm looking at negative h of x. So if you take your h of x function and put a negative out in front of every single term, it would change it to negative 2x squared. It would change this to a negative x, and it would change this to a positive 2. If it matches this one, it's odd. If it matches this one, it's even, right? But it didn't match either one. Do you agree? What we got out the bottom did not match odd or even, correct? So we say that it's neither. Gabe?
So when there's 3 terms and not out of 3 changes needed.
Correct.
Only from
All, it has to be all or nothing, okay?
Okay.
All or nothing, yeah.
What if there's 2 and 1 changes?
What if there's 2 and only 1 changes? It's still going to be neither, okay?
So they all have to change.
They all have to change signs, correct, okay?
For that, so groups of 3.
No. If there's 5 terms, how many of them need to change sign? 5 in order for it to be odd. Yes, Caitlin? Correct. All of them, though, the entire function, okay? Almost think about like a negative being distributed to 2x squared minus x minus 2, right? Plus x. Do you agree that you would distribute this negative to every single term? That's why they all change sign. Does that make a little bit more sense? Okay. All right, let's do another one. Let's do D.
Odd.
Ooh, odd. Why?
Because it's negative x.
F of negative x equals 5 times negative x.
And it just is negative 5x.
So it's negative 5x. Very good. This one is odd.
I don't even get what I have to do with
Oh,
it.
this was so easy.
Wait, who said even? It's okay.
Wait, is it even if it doesn't?
Who said that it was even?
Yeah, I think
It wasn't me.
What would have to change, like what would have to be down here for it to be even? 5x. It have to be the exact same thing. If the negative doesn't change your function, then it's even. If it does change the sign of your function, it's going to be odd. Okay. This is the hardest part of the lesson, guys. The second part is way easier, I promise, okay? All right, letter E. We have g of x equals 2 raised to the x power. What do I do? Plug in a negative. So it's going to be g of negative x equals 2 to the negative x. What do we do with a negative exponent? What?
You switch
You bring it down where?
under the fraction.
The bottom of what?
The fraction.
1 over 2 positive x.
Okay, so it's 1 over 2 to the x. Do you guys agree? Okay, hold on. Does this match this? No, so it's not what?
It's nothing.
It's not what? It's not even. Is this exactly one negative sign away from this? No. So is it odd? No, so what is it? Neither. It's not that easy, okay? But the more we practice, the better we get. Yes, Caitlin.
Is there 1 over 2? Is this like
Why is it 1 over 2 to the x? Hey, who can explain this step to me? How I got from here to here? Karen?
So basically, because the fraction can be negative, so you have to flip it. And
Not the fraction. A fraction can be the exponent. Very good. Do you remember when we had negative exponents? They always get moved to the other side of your fraction. Austin, go ahead. David? McCarvin, what's up? Let's take a look at letter F. We've got h of x equals 2x squared plus 3. Don't start working. Let's take a guess. What do you guys think? Okay, let's see if we're right.
have Matthew guess.
H of negative x equals 2 times negative x to the second power plus 3. Sophia, was that a hand? Can you help me? What do I do?
The x to negative x, so you get 2x to the 7 plus 3.
Does it match the original? Oh, yeah, it does. What does that mean it is? Even. Who said even from the start? Ballas.
I said neither.
I don't think I want to be an accountant.
I said
You don't want to be an accountant now?
I mean, no.
You don't need to know this to be an accountant. I don't think you need to know this. Okay, so you remember when we did... People, now for the easy part, okay? We are learning a new form of quadratic functions. And this form, you're going to want to write this down. It is much easier. This is called vertex form, okay? Why do you think it's called vertex form?
It finds the vertex.
It gives you the vertex, okay? Okay? Now, the only thing that's changed is they're adding in an h value here, right? Now, let's analyze that h value. What operation is in front of the h value?
Negative.
What operation is in front of the h value? A subtraction symbol. What do subtraction symbols typically mean in terms of the transformations they can cause? No, not a reflection.
Down.
Hey, remember, that would be a minus sign in front, right, Kaden? What does a subtraction symbol do? Translation. Very good. Now, is that minus h in opposite world?
Yeah.
It sure is. So if we're subtracting 4, where are we actually moving?
Up 4.
Not up 4.
Right.
To the right 4, okay? If we are adding 5, where are we actually moving?
To the left 5.
To the left 5, okay? So But the reason this form is so useful is because it gives you the exact location of your vertex, okay? So let's check out some examples. Let's look at our first example, letter A. Let's first identify what our transformations are, and then we'll actually graph the function, okay? So let's start with that -4 that we talked about. It is in opposite world. It is horizontal because it's inside the parentheses next to our x. Where do you think the -4 is going to move my graph? Caitlin? It would be outside the parentheses if it was vertical. It is horizontal to the right 4. It's a right shift by 4. Why is it to the right? It's an opposite world. So minus typically moves us left, correct? But in this case, we're moving to the right 4. Second question, there's another transformation here. Which one is the transformation? Caden? Very good. That 1/2, we treat it just like our A value. What does this do to my graph? Yeah, buddy. It's a vertical shrink by how much? By 1/2. Why is it a shrink, Caden? It's smaller than 1. Very good. All right, so how much did I say we're shifting it? To the right 4. So guess where we start? At the origin, 0, 0. But where are we moving? So move it to the right 4 units. Guess what? This is my?
Vertex.
That's my vertex.
Hooray.
Wait, what?
Go ahead.
Wait, Mr. Jurko, how do you know that's horizontal?
It was inside parentheses, correct?
I love this formula.
Okay. So I just found my vertex. What are the coordinates of my vertex?
1/2.
No. 4, 0. There it is. What is my axis of symmetry? What in the axis of symmetry have to go through the vertex? X equals 4. So now I just need to determine, okay, is my graph going to go up or is it going to go down? Okay. How do I know my graph is going up or down? The A value, right? If the A value is positive, what does that mean, Austin? It's going up. So guess what? We're done. Well, it should not be skinny. Why should it not be skinny? Because it was a shrink, okay? So if you draw this, right, and you make it look like this, are you going to get this full credit? No, you'll get points for the vertex, okay? But you have to take into account the second transformation, which was a shrink by 1/2. Am I going to be super particular about how much you shrink it?
Yes.
Not necessarily, okay? But it should not be skinny. What's up, Matthew?
Where are the 2 other points on the thing? Like,
So, Matthew, I'm telling you right now, you don't have to calculate those. If you want to, though, you could plug in 5 and you could plug in 3, right? For your x values. And you would find out that it's going to be 1/2, God bless you, on both. So you would know it has to go through here and here. If you want to do that, Matthew, by all means, go for it. You don't have to, okay? Keep talking to me. What questions do we have on this example? AJ.
How do you know what's going on?
How did I know it was going up? Someone else answer that for me.
The first part so hard.
How did I know it was going up? The A value was positive. Karen?
So you have to know both of the formulas.
Yes, you'll have to know both of the formulas.
What's the point of the chart?
What do you mean the chart? Oh, this? I added that on accident. You can cross it out. Sorry. Yes. If it was a stretch, yes, then it would be skinny. Okay? It's going to be fat and wide. Okay? All right. Let's talk about it. Letter B. Okay, A value is 2, and that's positive, so it's going to look like this. Love that. But what kind of transformation is the 2 having, Sophia? Yeah, buddy. Vertical stretch by 2. There's another transformation. Caitlin? Yes. Shift left by 5. Oh, yes, it is short. Well, how do I know that this has to be horizontal? What word in here identifies horizontal? Left, right? So because it's going to the left, I would be okay if you don't put horizontal here, right? So let's shift our graph to the left by 5. That means where's my vertex? -5, comma 0. My axis of symmetry is x equals -5. Good job, Salucci. And then last thing, guys, is it facing up or down? And is it skinny or fat? Skinny. So make it skinny and make it face up. That's all I want. Why is it skinny? Caden? It's being vertically stretched by 2. Now, are you allowed to plug in -6 and -4 and make your own little chart just to make sure? By all means, go for it. But am I going to be checking for that from now on? No.
Are you going to be checking for the word things?
The what?
The transformation?
Yes, absolutely. We need to know those. Okay? Go ahead. You suck at those?
I still don't know, like,
I'm still.
You know, we'll get better. We'll get better. Okay? We're going to do a lot of it today.
I certainly am better than the beginner.
There we go. Natalie gets it. Okay.
It's not, it still has up.
I am very disappointed in what we answered this problem on the quiz. Okay? This was not on the quiz, but a lot of us, I'll show you what we did. We put a 1 here, which I was happy about because there is technically a -1 there. But we said that that 1 is stretching our graph by a factor of 1. It is not stretching our graph. It is not shrinking our graph. It's a reflection. Thank you, Austin. Because it's only -1. Okay, this is a reflection. And then -2. What's the -2 doing, peeps? Shift where? To the right by 2. Okay, so where's my vertex going to be? 2, comma 0. Is it stretched or shrinked at all? No, but what's changing?
it's going to be a -2.
It's going down.
It's going down. Very good, Mateo. Kira, I mean, does it have to be perfect? No. Okay. Can you say that one more time? All right.
That doesn't look very accurate.
What? It's 2, comma 0. Why is it 2, comma 0? Because the x goes first, okay? Mia, where would 0, comma 2 be?
2 down.
Yeah, on the y-axis, okay? All right, guys, that's it for example C. Yeah, it should have been an n-looking graph, okay? Okay, the only other thing you need to know is that when they add this k value, okay, that's going to add an extra shift, but where?
Oh my gosh, I thought it was down.
Up or down? It's up if that k value is positive, and it's down if the k value is. There we go. So all we're going to do for these last examples is we're going to locate where the vertex is. So in example A, let's go ahead and write the word vertex. So how has it been shifted left or right in this example? It's been shifted to the left 2 because of the +2. Do you guys agree? So the x value of my vertex is what? It's going to be -2 because we shifted it to the left 2. And then how much was it moved up or down? Up 3. So the y value of my vertex is? -2, comma 3. That's it.
What about the first?
So this means that it's going to be reflected and then stretched by 2, okay? We kind of touched on that in the previous one, so I'm not going to go over that again. All I really care about is that we're able to use the vertex form for what it's designed to do. And it's designed to give you your vertex, okay? What's up?
Did the last question have a U? Was it a U or an N?
That was an N. It was reflected. All right, let's look at the next one. Let's take a look at B. All I want to know is where is this vertex? 1, comma 6. Why, AJ? right 1, and up 6. All right, let's do our last one, which is letter C. Thank you.
Negative 4.
Very good. The vertex is going to be at -4, -2.
Do we have to show any work for this?
Nope. All right, guys, when you're done with this one, go ahead and turn it in. What? There's 19.